Hello students, welcome to Breedmark Academy. Myself L.S. Nanda. Now in today's video, I am going to discuss the solutions of two mathematics questions that were asked in recently held JEE Advanced 2025 Paper 2 exam. Now this is the first question of the video and this question is based on the topic of ellipse. It says let P x1, y1 and Q x2, y2 be two distinct points on the ellipse x square upon 9 plus y square upon 4 equal to 1 such that y1 greater than 0 and y2 greater than 0. Let C denote the circle x square plus y square equal to 9 and M be the point 3, 0. Suppose the line x equal to x1 intersects C at R and the line x equal to x2 intersects C at S such that the y coordinates of R and S are positive. Let angle ROM equal to pi by 6 and angle SOM equal to pi by 3, where O denotes the origin 0, 0. Let mod of xy denote the length of the line segment xy. Then which of the following statements are true? The first option is the equation of the line segment P and Q is 2x plus 3y equal to 3 into inside the bracket 1 plus root 3. The second option is the equation of the line joining P and Q is 2x plus y equal to 3 into inside the bracket 1 plus root 3. The third option is if n2 equal to x2, 0, then 3 into mod of n2q equal to 2 into mod of n2s. And the last option is if n1 equal to x1, 0, then 9 into mod of n1p equal to 4 into mod of n1r. Now students, basically in this question, we have to find the equation of the line PQ and we have to relate the lengths of the line segments n2q and n2s, and also we have to relate the lengths of the line segments n1p and n1r. Now you can see the figure of the given question. We have an ellipse x square upon 9 plus y square upon 4 equal to 1, which is intersecting the positive x-axis at the point M 3, 0. O is the origin and there are 2 points P and Q lying on this ellipse. The coordinates of P and Q are x1, y1 and x2, y2 respectively, where y1 is greater than 0 and y2 is also greater than 0. There are two lines x equal to x1 and x equal to x2 which are intersecting the auxiliary circle of this ellipse at points R and S respectively, where the y coordinates of the points R and S are both positive. Now students, we know that the equation of the auxiliary circle for the ellipse x square upon a square plus y square upon b square equal to 1, where a is greater than b, is x square plus y square equal to a square. Now here for this ellipse, a is greater than b and a is equal to 3. So this means the equation of the auxiliary circle for this ellipse is x square plus y square equal to 9. This clearly implies that the given circle is the auxiliary circle for this ellipse. Now students, we are also given that angle ROM is equal to pi by 6 and angle SOM is equal to pi by 3. This clearly implies that the eccentric angles of the points P and Q are pi by 6 and pi by 3 respectively. Now we know that if theta is an eccentric angle for a point lying on the ellipse x square upon a square plus y square upon b square equal to 1, then the coordinates of this point are a cos theta, b sin theta, and the coordinates of its corresponding point on the auxiliary circle are a cos theta, a sin theta. So this means the coordinates of the point P are a here is 3, so 3 into cos pi by 6, b here is 2, so 2 into sin pi by 6. Now just put the values of cos pi by 6 and sin pi by 6. The coordinates of P are 3 root 3 by 2, comma 1. Now similarly, we can find the coordinates for the point Q. The coordinates of point Q are 3 into cos pi by 3, comma 2 into sin pi by 3. Just put the values of cos pi by 3 and sin pi by 3. So it becomes 3 by 2, comma root 3. Now students, we can easily find the equation of the line PQ by using 2-point form. Now, first of all, let's find the slope of the line PQ, which is y2 minus y1 upon x2 minus x1. It becomes root 3 minus 1 divided upon 3 by 2 minus 3 root 3 by 2. Now you can take out 3 by 2 common from the denominator, and root 3 minus 1 gets cancelled up and down to give minus 1 in the denominator. So finally it becomes minus 2 upon 3. Now students, we find the equation of the line PQ. Now students, equation of line PQ is y minus root 3 equal to minus 2 upon 3 into inside the bracket x minus 3 upon 2. Now this can further be written as y minus root 3 equal to minus 2x upon 3 plus 1. This can further be written as y plus 2x upon 3 equal to root 3 plus 1. Now this can further be written as 3y plus 2x whole divided upon 3 equal to root 3 plus 1. Or finally, the equation of line PQ is 2x plus 3y equal to 3 into inside the bracket root 3 plus 1. So that means option A is the correct one. Now students, to check the options C and D, we will have to find the coordinates of the points R and S. Now the coordinates of points R and S are given by the coordinates a cos theta, comma a sin theta, where a is equal to 3 for both the points and theta is equal to pi by 6 for the point R and theta is equal to pi by 3 for the point S. So that means the coordinates of the point R are 3 cos pi by 6, comma 3 sin pi by 6, and the coordinates of the point S are 3 cos pi by 3, comma 3 sin pi by 3. Now students, the coordinates of R become 3 root 3 by 2, comma 3 by 2, and the coordinates of the point S become 3 by 2, comma 3 root 3 by 2. Now students, in the question we are given 2 points n1 and n2, where n1 is x1 comma 0 and n2 is x2 comma 0. Now the value of mod of n1 r, that means the length of the line segment n1 r, is nothing but the y coordinate of the point R, which is equal to 3 by 2, and the value of mod of n2s, which is nothing but the length of the line segment n2s, is the y coordinate of the point S, and this is equal to 3 root 3 by 2. Now students, we move further. Now similarly, mod of n2q is equal to the y coordinate of the point Q, which is equal to root 3, and mod of n1p is equal to the y coordinate of the point P, which is equal to 1. Now in the option C, it is given that 3 into mod of N2Q is equal to 2 into mod of N2S. Now let's check whether it is correct or not. Now left hand side becomes 3 into root 3 and right hand side becomes 2 into 3 root 3 by 2. Now this is equal to 3 root 3. This means LHS is equal to RHS, or option C is the correct one. Now students, we check the option D. In option D, it is given that 9 into mod of N1P is equal to 4 into mod of N1R. Now left hand side becomes 9 into 1, which is equal to 9, and right hand side becomes 4 into 3 by 2, which is equal to 6. Now clearly 9 is not equal to 6. So this means left hand side is not equal to right hand side, or option D is not correct. So finally we conclude that option A and C are correct for this question. Now students, we move towards the next question. Now students, this is the next question. This question is based on the topic of application of derivatives. It says, let R denote the set of all real numbers. Let FR to R be defined by f of x equal to 6x plus sin x whole divided upon 2x plus sin x if x not equal to 0, and f of x equal to 7 upon 3 if x equal to 0. Then which of the following statements is R true? The first option is the point x equal to 0 is a point of local maxima of f. The second option is the point x equal to 0 is a point of local minima of f. The third option is number of points of local maxima of f in the closed interval pi, 6 pi is 3. The last option is number of points of local minima of f in the closed interval 2 pi, 4 pi is 1. Now students, we start solving this question. Now students, in the first two options, we have to decide whether x equal to 0 is the point of local maxima or point of local minima for the function f of x. Now for this purpose, we will have to find the derivative of f of x at x equal to 0. Now since it's a branched function, at x equal to 0, f of x is 7 upon 3, and for x not equal to 0, f of x is 6x plus sin x whole divided upon 2x plus sin x. So we will find left hand derivative at x equal to 0 and right hand derivative at x equal to 0, and then check whether both of them are equal to 0 or not. Now students, LHD at x equal to 0 becomes limit h tending to 0 f of minus h minus f of 0 whole divided upon minus h. Now this further becomes limit h tending to 0 minus 6h minus sin h whole divided upon minus 2h minus sin h minus 7 upon 3 whole divided upon minus h. Now this further becomes equal to limit h tending to 0 6h plus sin h whole divided upon 2h plus sin h minus 7 upon 3 whole divided upon minus h. Now minus I am taking outside the limit. It becomes limit h tending to 0. In the denominator we have 3h into inside the bracket 2h plus sin h, and in the numerator we get 18h plus 3 sin h minus 14h minus 7 sin h. Now this becomes equal to minus limit h tending to 0, 4h minus 4 sin h. So 4 I can take out common, and inside the bracket I get h minus sin h whole divided by 3h into inside the bracket 2h plus sin h. Now students, this further becomes equal to minus 4 upon 3 limit h tending to 0, h minus sin h whole divided upon 2h square plus h sin h. Now students, if you put h as 0 in the numerator and denominator, the form of the limit becomes 0 by 0 form. So that means we can apply L'Hospital's rule because both numerator and denominator are differentiable functions and the form of the limit is 0 upon 0. Now students, we move further. Now students, f dash 0 minus becomes equal to minus 4 upon 3 into limit h tending to 0. Now after applying L'Hospital's rule, the numerator becomes 1 minus cos h and denominator becomes 4h plus h cos h plus sin h. Now again this limit is of the form 0 by 0. So we will apply L'Hospital's rule again. It becomes minus 4 upon 3 into limit h tending to 0 sin h whole divided upon 4 plus cos h plus cos h, which becomes 2 cos h minus h sin h. Now students, when we put h equal to 0 in this limit, we get minus 4 upon 3 into 0 upon 6, which is just equal to 0. So that means f dash 0 minus is equal to 0. Now we find the right hand derivative at x equal to 0. So f dash 0 plus becomes equal to limit h tending to 0 f of h minus f of 0 whole divided upon h. Now this is equal to limit h tending to 0 6h plus sin h whole divided upon 2h plus sin h minus 7 upon 3 whole divided upon h. Now students, the value of this limit is equal to the value of the previous limit because minus 0 is equal to 0. So from here we conclude that f dash 0 minus is equal to f dash 0 plus is equal to 0. That means the function f of x is differentiable at x equal to 0 and its derivative at this point is equal to 0. Now students, to further ensure whether it is local minima or local maxima at this point for the function f of x, we will find f dash x when x is not equal to 0 and use first derivative test. Now students, we move further. Now students, f of x is equal to 6x plus sin x whole divided by 2x plus sin x when x is not equal to 0. Now numerator can be written as 4x plus 2x plus sin x. So this means f of x is equal to 1 plus 4x divided upon 2x plus sin x when x is not equal to 0. Now from here we get f dash x equal to 2x plus sin x whole square in the denominator and in the numerator we get 2x plus sine x inside the bracket into 4 outside the bracket minus 4x into inside the bracket 2 plus cos x. Now students, f dash x further becomes equal to 8x and minus 8x get cancelled, and when we take out 4 common, inside the bracket we get sin x minus x cos x. Now students, when we take out cos x common from the numerator, it becomes 4 cos x into inside the bracket tan x minus x. And in the denominator it is 2x plus cos x whole square. Now students, we move further. Now students, we have got f dash x equal to 4 cos x into inside the bracket tan x minus x divided upon 2x plus sin x whole square. Now we know that f dash 0 is equal to 0. But to decide whether at x equal to 0 it is local minima or local maxima, we will have to apply first derivative test. And for this purpose, we will have to find the sign of f dash x in the left and right neighborhood of x equal to 0. Now students, when x is slightly smaller than 0, then cos x is positive because x lies in the fourth quadrant, and tan x is smaller than x. So that means tan x minus x is negative. And denominator is a perfect square quantity which is always positive. So this means the sign of f dash x in the left neighborhood of x equal to 0 is negative. And when x is slightly greater than 0, that is in the right neighborhood of x equal to 0, the sign of f dash x is positive, because this time tan x is greater than x, which means tan x minus x is positive, and cos x is also positive because x lies in the first quadrant, and denominator is again positive. Now students, since there is a transition in the sign of f dash x in the neighborhood of x equal to 0 from negative to positive sign, so clearly it is a point of local minima for the function f of x. Now students, in the remaining two options, we have to find the total number of points of local maxima or local minima in the given intervals. Now, to find all such points, we will have to put f dash x equal to 0. Now, when I put f dash x equal to 0, then cos x equal to 0 is not possible. Only tan x equal to x is possible. Why? Because when we put cos x equal to 0, then sin x will become equal to 1. So clearly, the numerator of f dash x does not become 0, because originally the numerator of f dash x was 4 times inside the bracket sin x minus x cos x, which does not become 0 when we put cos x equal to 0. So this is not possible. So clearly, all the points of local maxima or local minima for the function f of x will be given by the roots of tan x equal to x. Now students, we will make the graph of tan x and the line y equal to x and find the points of intersection of these two graphs, and then we will decide how many points of local maxima and minima are there in the given intervals. Now let's move further. Now students, in this graph, you can clearly see all the red curves are representing the graph of y equal to tan x in the closed interval 0, 6 pi, and the green line is representing the straight line y equal to x. Now clearly, the straight line is intersecting the graph of tan x in 6 points in this interval, including x equal to 0. Apart from x equal to 0, they are intersecting in 5 points whose x coordinates are x1, x2, x3, x4 and x5. Now students, x1, x3 and x5, they all lie in the third quadrant, and x2 and x4 lie in the first quadrant. In the left neighborhood of x1, x3 and x5, cos x is negative and tan x is smaller than x. And the denominator of f dash x, which is 2x plus sin x whole square, is always positive. So that means I can say that in the left neighborhood of x1, x3 and x5, the sign of f dash x is positive. Whereas in the right neighborhood of x1, x3 and x5, since tan x is greater than x, which means tan x minus x is positive. So the sign of f dash x changes to negative. So there is a transition from positive to negative sign in the neighborhood of x1, x3 and x5. So clearly they represent the points of local maxima. Whereas for the points where x is equal to x2 and x is equal to x4, since they lie in the first quadrant, cos of x is positive, and in their left neighborhood, tan x is smaller than x, which means tan x minus x is negative, and the denominator of f dash x is already positive. So that means in the left neighborhood of x2 and x4, f dash x is negative. And in the right neighborhood of x2 and x4, since tan x is greater than x, which means tan x minus x is positive. So this means f dash x changes to positive sign. Now since there is a transition from negative to positive sign in the neighborhood of x2 and x4, so clearly they represent the points of local minima. Now students, in the option C, it is mentioned that there are 3 points of local maxima for the function f of x in the closed interval pi to 6 pi. Now this statement is correct because clearly from the graph we can see that x1, x3 and x5, they all lie in this interval. So there are 3 points of local maxima for this function in the closed interval pi to 6 pi. So that means option C is correct. And in the option D, it says there is 1 point of local minima for the function f of x in the closed interval 2 pi to 4 pi. Now students, in this interval, only x2 lies, x4 does not lie. So this means there is only 1 point of local minima for the function f of x in closed interval 2 pi to 4 pi. So this means option D is also correct. So finally we conclude that B, C and D, these 3 options are correct. Now students, this is to inform you that I have created 2 separate playlists of paper 1 and paper 2 for JEE Advanced 2025 math solutions. So you can go to the playlist section of my channel and watch all of these videos. Keep watching my videos and enhance your knowledge of mathematics. Thanks.